At the heart of the Milky Way lies a colossal star nearing the final stages of its life. This star, known as Betelgeuse, has sparked much speculation among astronomers about the possibility of becoming a supernova at any moment. While some space enthusiasts have acquired advanced telescopes to observe the phenomenon, others are concerned about potential impacts on Earth and have already begun seeking shelter. The fascination with Betelgeuse is not just due to its sheer size or luminosity but also because it represents one of the most dramatic and awe-inspiring events in the universe, the death of a massive star. One observer even started a 24/7 live stream on YouTube, showing the position where Betelgeuse can be most clearly seen. However, it's now 2025, and no explosion has occurred yet. This raises questions: what's happening with Betelgeuse? When will it finally explode? And what would the consequences be for Earth? These are questions that have intrigued scientists and amateur astronomers alike for decades. Betelgeuse's erratic behavior over the past few years has only added fuel to the fire of speculation, making it one of the most closely monitored stars in the night sky. Before we continue, don't forget to like the video, subscribe to the channel, and turn on notifications so you don't miss any content. Now, let's dive deeper into the fascinating story of Betelgeuse and explore why this star has captured the imagination of humanity. In September 2022, the James Webb Space Telescope captured stunning images of the Orion Nebula, highlighting Betelgeuse in all its glory. The star is the 10th brightest in the sky and the 7th most visible across much of North America, Europe, and Canada. Its luminosity is so intense that it can be seen with the naked eye from Earth, despite being located approximately 530 light-years away, a figure revised downward from earlier estimates of 650 light-years. Betelgeuse is classified as a red supergiant, one of the largest types of stars in the universe. To put its size into perspective, if Betelgeuse were placed at the center of our solar system, it would engulf the orbits of Mercury, Venus, Earth, Mars, and possibly even Jupiter. Initially, it was thought that Betelgeuse was about 887 times the size of the Sun, but more recent studies suggest it's approximately 764 times larger. Even with this adjustment, Betelgeuse remains an astronomical giant, dwarfing our Sun in both mass and diameter. What makes Betelgeuse particularly intriguing is its pulsating nature. Unlike stable stars like our Sun, Betelgeuse is constantly shrinking and expanding, surrounded by at least 6 layers of matter that it ejects into space. Every 10,000 years, it loses an amount of mass equivalent to that of our Sun. This mass loss is a critical factor in understanding the star's life cycle and its eventual fate. Betelgeuse has changed color multiple times over the centuries, as revealed by researchers at the University of Jena in Germany. 2,000 years ago, it was yellow, then orange, and now red, though it may soon return to being a yellow supergiant. These color changes are not random but are indicative of shifts in the star's temperature and chemical composition. In 2019, Betelgeuse presented another mystery when a significant portion of it suddenly disappeared. For several months, the star dimmed dramatically, leading to widespread speculation about its imminent demise. Although some theories suggested the involvement of extraterrestrial civilizations siphoning energy from the star, scientists dismissed the idea. Instead, studies indicate that a massive explosion occurred, ejecting an enormous amount of plasma and creating a dense cocoon of dust around part of the star. This dust cloud temporarily obscured Betelgeuse from view, making it appear dimmer from Earth. Between 2019 and 2020, the Hubble Space Telescope recorded changes in Betelgeuse's brightness as it recovered from this event. Historical observations show that its eruptions occur every 420 days, but recently this cycle has changed. In 2020, the Solar Terrestrial Relations Observatory detected a drop in the star's brightness earlier than expected. Additionally, it seems that Betelgeuse has already consumed all available hydrogen and is running out of helium, which usually precedes a supernova explosion. Astrophysicists at Cornell University proposed in 2022 that if red giant stars are enveloped in dense layers of matter, they could explode within a few years. However, Currently, Betelgeuse does not have such a dense layer, and different estimates suggest its explosion may occur in up to 100,000 years or even 1.5 billion years. Nevertheless, this does not rule out the possibility of an imminent supernova, as some stars form their death cocoons rapidly. If Betelgeuse were to explode, the neutrinos emitted could alert scientists just a few days before the event. Neutrinos, often referred to as ghost particles, are produced in vast quantities during the core collapse phase of a supernova. They travel at nearly the speed of light and can pass through matter almost undisturbed, making them an early warning system for astronomers. If detectors on Earth pick up a sudden surge in neutrino activity from Betelgeuse, it would signal that the star is on the brink of exploding. A supernova explosion could release energy equivalent to more than 10 billion suns, generating gamma rays capable of devastating any planet in its path. NASA suggests that a similar event may have occurred on Earth 450 million years ago, causing one of the largest mass extinctions in history. During this event, a gamma-ray burst likely stripped away half of Earth's ozone layer, exposing life on the planet to harmful ultraviolet radiation and triggering widespread ecological collapse. Fortunately, Betelgeuse is far enough away from Earth that its explosion would pose no direct threat to our planet. Astronomers estimate that only stars within 50 light-years of Earth could cause significant harm if they went supernova. At 530 light-years away, Betelgeuse is well beyond this danger zone. However, its explosion would still be a spectacle of cosmic proportions, visible even during the daytime for several weeks or months. Recent events, such as the GRB 22009 explosion in Sagittarius and the SNR 0519 supernova in the Large Magellanic Cloud, occurred at safe distances from Earth. GRB 22009, detected in October 2022, was one of the most powerful gamma-ray bursts ever observed, traveling nearly at the speed of light. It originated 2.4 billion light-years away, far enough to spare Earth from its destructive effects. Similarly, the SNR 0519 supernova, located 160,000 light-years away in the Large Magellanic Cloud, posed no threat to our planet. When Betelgeuse eventually explodes, it will leave behind either a neutron star or a black hole, depending on the mass of its remaining core. The explosion will scatter heavy elements like iron, gold, and uranium across the galaxy, enriching the interstellar medium and potentially seeding new star systems. This process is a fundamental part of cosmic evolution, as the materials ejected by supernovae go on to form planets, moons, and even life itself. For now, Betelgeuse remains a beacon of mystery and wonder, reminding us of the vastness and complexity of the universe. Whether it explodes tomorrow or millions of years from now, its legacy will endure as a testament to the dynamic and ever-changing nature of the cosmos. This outcome is determined by the intricate balance between gravitational collapse and the outward pressure generated by the explosion. If the core's mass exceeds approximately 2 to 3 times that of our Sun after the supernova event, it will collapse into a black hole. Otherwise, it will form a neutron star, an ultradense remnant composed almost entirely of neutrons, with a teaspoon of its material weighing billions of tons. The explosion itself will be nothing short of spectacular. For Earth-based observers, Betelgeuse's supernova would shine as brightly as a full moon in the night sky, casting shadows even during the daytime for weeks or months. Its luminosity could rival that of an entire galaxy for a brief period, making it one of the most visually stunning events humanity has ever witnessed. Ancient civilizations recorded similar phenomena. For instance, the supernova SN 1054, which created the Crab Nebula, was documented by Chinese astronomers who described it as a guest star visible even during daylight hours. Beyond its visual grandeur, the explosion will scatter heavy elements like iron, gold, uranium, and other materials essential for life across vast regions of space. These elements are forged in the intense heat and pressure of a dying star's core and released during the cataclysmic explosion. This process, known as nucleosynthesis, is how the universe enriches itself with the building blocks necessary for planets, stars, and ultimately, life. In fact, the atoms in your body, carbon, oxygen, calcium, and more, were likely formed in the hearts of ancient stars that met their demise in supernovae billions of years ago. Betelgeuse's death will continue this cosmic cycle, contributing to the ongoing story of stellar evolution. Betelgeuse's eventual explosion serves as a poignant reminder of the impermanence of all things, even on cosmic scales. Stars, despite their immense size and power, have finite lifespans dictated by the laws of physics. Yet, their deaths are not endings but beginnings. They sow the seeds for future generations of stars, planets, and perhaps even life. This interconnectedness underscores the profound beauty of the universe. Every atom, every photon, every ripple in spacetime is part of an unbroken chain stretching back to the Big Bang. For humanity, observing such an event would be both humbling and inspiring. It would remind us of our place in the cosmos, not as passive spectators, but as active participants in understanding and exploring the mysteries of the universe. The tools we've developed, telescopes like Hubble, James Webb, and neutrino detectors, are testaments to our curiosity and ingenuity. They allow us to peer into the depths of space and time, unraveling the secrets of stars like Betelgeuse and deepening our appreciation for the intricate dance of forces that govern existence. What lies ahead? While scientists cannot predict the exact moment of Betelgeuse's explosion, they remain vigilant, monitoring its behavior through advanced instruments and simulations. Every flicker, dimming episode, or outburst provides valuable data that helps refine models of stellar evolution. For now, Betelgeuse continues to pulse and shimmer in the constellation Orion, a steadfast presence in our night sky. But when it finally does explode, whether tomorrow or millennia from now, it will mark a turning point in human history, a shared experience that transcends borders, cultures, and generations. Imagine standing under a clear night sky, watching as Betelgeuse transforms into a radiant beacon, brighter than anything else in the heavens. It would be a moment of collective awe, uniting people around the globe in wonder and reflection. Such events remind us that while our lives are fleeting, the universe endures, offering endless opportunities for discovery and inspiration. So, what do you think about all this? Do you believe Betelgeuse will explode in our lifetime, or will it bide its time for thousands, or even millions, of years? How do you feel about the idea of witnessing a supernova firsthand? Leave your thoughts in the comments below, and let's discuss this incredible cosmic phenomenon together. If you enjoyed this deep dive into Betelgeuse, don't forget to give the video a thumbs up, subscribe to the channel, and hit the notification bell so you never miss an update. Exploring the mysteries of the universe is a journey we embark on together, and your support means the world to us. Thanks for watching the News Forge, and until next time, keep looking up at the stars. They hold stories far greater than we can imagine.